Hi. Since you're watching this presentation, I assume you're already well aware of the problems we are facing with social media today, and now you're looking for a better approach. Or you simply heard about this new protocol and now you want to find out more. My name is Stefan Kopf and I'm going to present the Social Profile Exchange Protocol as a novel approach to overcome social networks as we know them today. This will mainly be a technical presentation where we look at the actual protocol, requiring some moderate technical understanding. But before we dive into protocol design, I would like to quickly discuss how we ended up here. In the 80s, we had these so-called network service providers like CompuServe, AOL, or Prodigy. They offered a closed platform on which you could find services from electronic mail, weather forecast, news, to e-commerce and even banking. Users have been locked in on these platforms with almost no interconnectivity. These platforms then have been broken up in the 90s by the emerging internet, where clever engineers just defined how independent systems talk to each other and left it to implementers to come up with the actual applications. And this then created a massive ecosystem where smart companies started to compete against each other for the best solution and the best application. This offered customers now a wide variety of applications to choose from. So today you can freely choose between Firefox, Chrome, Edge or Safari as your favorite web browser. And you can choose between Apache, Nginx, Internet Information Server and a lot of others as your web server. And if you do not want to run your own web server, you can even delegate this task to one of the many web hosting companies out there. All of this is based on the HTTP communication protocol and the HTML standard. And the situation is quite similar with email, where we have these POP3, SMTP and IMAP protocols. However, with social networks, this has somehow completely failed. And we are now back to a few centralized platforms acting as gatekeepers for users' content. There have been multiple attempts to change this, but unfortunately none of them really succeeded. And you can easily tell this from looking at this slide. You might most likely recognize most of the logos on the left-hand side, but almost none of the logos on the right side. One of the reasons might have been that some of these approaches focused too much on technical details and did not take the user experience into account. So without addressing the actual user's needs and problems, there has simply been no incentive for users to switch over. Another reason might have been that some of these approaches provided the actual software rather than just defining the protocol. And this software then has been provided by a quite restrictive open source license like GPL or AGPL, effectively locking out all commercial actors. There are even research papers out there discussing why these standardization processes have failed, like the one we can see here on the screen. We are now trying to change this with the Social Profile Exchange Protocol, or SPXP in short. This initiative tries to foster a whole ecosystem of various applications and solutions which then conjointly form a social network which will neither be owned nor controlled by any single entity. Very similar to what we have with the World Wide Web today. Ideally, users will then have the choice between a variety of different client applications to participate in this network, and they will be able to either run a server themselves or simply pick one of the many profile hosting companies. By breaking up the centralized social networks, we hope to be able to spark innovation in this field as well, just as we've seen in the World Wide Web in the late 90s, where companies then suddenly used these hypertext technologies for completely different tasks far beyond the intended initial use. For example, to book flights online, or to sell books, or to find a restaurant, or to order pizza. We based the Social Profile Exchange Protocol on well-established, rock-solid open standards, like HTTP for data transport, JSON to encode structured data. We use AES and Curve 25549 cryptographic primitives, then wrapped into the JavaScript object signing and encryption framework, JOS. You might not have heard this JOS framework yet, but you have probably already seen it. These JSON Web Tokens, JWT, they are also based on this framework. In a nutshell, a profile in SPXP is simply a JSON document referenced by a URI, the so-called profile URI. This JSON document then describes this profile with a name, for example John Doe here, some short description, probably some longer about text, but also date of birth or geodetic coordinates. We can also reference additional resources and services from here. For example, a JPEG image on a web server to act as a profile picture, or we can reference a website or an email address. Now, to form a social graph, these profiles can reference each other, quite similar to anchor links in HTML. Here we can see an example where this profile references the profile of the city of London as its hometown, and it references the profile of Berlin as its current location. And that's basically all you need to know to get started. If you want to participate with your own profile, then all you need to do is craft such a simple JSON document and put it somewhere on your web server. And that's already it. It's really that simple. There's also additional information which is not part of this JSON document, and this information is then provided by additional endpoints which are declared here, like the friends endpoint we can see here at the bottom. Behind this URI, you can then find another JSON document which contains a list of exactly these profile references pointing to profiles which are considered friends. There is also a time series of updates provided by a profile known as posts. These are then again behind an additional endpoint, the posts endpoint, which is again declared here as you can see at the bottom. These posts can then be in the form of a simple text post, like this hello world message we can see here, or they can reference a picture or video on a web server, like this photo post we can see here, or they can point to a web page, like this web post here. Each of these posts has a so-called sequence timestamp, linking this post to a unique point in time in this time series. A client can then use additional parameters on the post endpoint to only get posts before or after a certain point in time. This can then be used to page through these posts, for example, while a user is scrolling through the timeline of a profile, or a mobile app could use it to only get new posts in the background while the user is inactive. This entire protocol design is intentionally kept as simple as possible to be as inclusive as possible. With this simple, straightforward design, it is now possible to add this protocol quickly to any existing web content management system. For example, if you want to expose your personal blog through this protocol. Or a news corporation could adopt this protocol to publish their breaking news as posts. And basically any small business or organization which currently already has a website can quickly add such a profile to their web server. While this is really great for all the use cases where we already have a website, this is simply not how an average user wants to consume a social network. Nobody really wants to run a web server just to participate in social networking. Instead, what will happen is that service providers will come up with offerings to host such a profile for you. And this is actually something that is intended and very much welcomed. However, we might again run into situations where users are then logged into these service providers. And you can observe this today with email. Once you started to use your email address for multiple different accounts, then it's not that simple to switch to a different email provider, because your email address is bound to the domain of your provider. To prevent this with SPXP, we bind profiles to a cryptographic key pair rather than the URI. A profile has the option to publish a curve25519 public key, and this happens in JWK, the JSON Web Key format, as we can see here on the screen. Once a profile exposes such a key, then all information must be signed by this key, as we can see here in the bottom in the signature block. And this applies not just to this profile document here, but also to the friends list and to all posts. And these posts then need to be signed individually so that the server is still able to filter out posts by date, but without needing to know the private signing key. If there's such a key on the profile, then this takes always precedence over the profile URI. So this URI then is just one option how to get information about this profile. But this profile can start to publish on a different web server immediately, or even outside of HTTP and just put updates on IPFS, or even just physically and store these updates on a thumb drive in the case there is no internet connectivity. Profile references then also combine this public key with a profile URI and give the public key always precedence. So if a profile with the same key is on a different URI, then this profile still fulfills this reference. And also the other way around, if a profile behind a profile URI is suddenly presenting a different public key, then this profile is not considered to be the referenced profile. It is now important to note here that these signatures can only verify that all information is signed by an actor knowing the private signing key, but they do not authenticate the identity behind the profile. Everybody can create a profile with the name John Doe. Trust in the actual identity is then built by a web of trust. For example, if multiple of your connected friends all have this Crypto Alice profile in their friends list, then it's safe to assume that this is the Alice you know from real life. A protocol client could then mark this protocol in a specific way, as we can see here in this example. Until this point, SPXP is nothing more than a nice publishing service, just with a slight social networking touch. But it does not really provide any big advantages over protocols like AtomPub or RSS. For a social network, we need to have the possibility to address different audiences. There is some information out there I'm happy to share with everybody, like my name or my website, because this is indexed by Google anyway, right? But there's also other information, like my email address, I only want to share with my friends and my work colleagues. And then there's some really sensitive information I really only want to share with my family and my close friends. And this includes my service provider as well. I do not want the company who hosts my profile to know any sensitive information about me, and then maybe even to use the sensitive information to optimize my advertisement experience. SPXP can provide all of this by applying real end-to-end encryption on selected pieces of information. Let's assume you don't want to share your email address and your date of birth with everybody. Then you can remove these values from this profile document and put them into a separate JSON document. This document is then encrypted with AES, and the ciphertext is then represented as an JWE object after the JSON Web Encryption standard. This JWE object is then inserted back into your profile document as one element in this private array here. Everybody who knows the encryption key can then decrypt this object again and merge it back into the main JSON document. JWE would allow us to encode an object for multiple recipients, but considering their potentially large number, this is simply not practical. But also just using one single key and sharing it with all the recipients is not practical either. In the case we want to remove one of the individuals, then we would need to redistribute the new key to all remaining recipients. SPXP now solves this by encrypting each object with a unique content encryption key, and then encrypting this content encryption key again with a key encryption key in a process which is typically known as key wrapping. And this can be a multi-stage process, so this key encryption key can then be encrypted again with another key encryption key. This gives now the possibility to arrange these keys in a graph-like structure where we can address multiple audiences and are still able to structure this graph to optimize key distribution. Let's have an example. A profile might want to address two different audiences, friends and close friends. Now, the content encryption key of each post, which should only be visible to friends, is then wrapped by a key from this friends group. And the same with a post should only visible for close friends. This content encryption key then wrapped by a key for close friends. Now, close friends should also be able to view all posts which are addressed to friends, because close friends are considered a real subgroup of our friends. Then we can organize these groups in a way so that keys from the close friends group are able to decrypt keys from the friends group. Our dear friend Alice now has a personal reader key, and with her personal reader key she can then decrypt the keys for the close friends group, and with these keys she can decrypt keys from the friends group, and then finally with these keys she can decrypt the content encryption keys for each of these posts. Each of these groups now represents a whole stream of so-called round keys rather than a single key. So if we decide to remove a reader from the audience, like the rightmost friend here, then we just need to roll the round keys of this group, but we do not need to regenerate all the keys. To get these intermediate keys, a client then needs to use the keys endpoint, which is again declared here in this profile document. This endpoint is then provided with the ID of the reader key, as well as a list of target key IDs you need to access the information. The server then responds with a JSON document containing all the intermediate keys between the reader key and the required target keys. These reader keys can now be distributed among your audience by any means alongside this protocol, for example by email. But this would again not really be a great user experience. Instead, social networks typically offer a process of friending or linking or following, where two individuals agree to give each other extended access to their profiles. In SPXP, we call these connections, and we offer a secure connection process to mutually exchange cryptographic material, like these reader keys. If a profile accepts connection requests, then it announces a connect object as part of the profile JSON document. In there, the profile then specifies the public part of an asymmetric encryption key, as well as an endpoint on the server which receives connection requests on behalf of the user. Let's assume Alice wants to connect with John's profile. She then would create a new reader key for John and encrypt this reader key into a connection package for John. Both are then stored on Alice's profile server, and they are associated with a unique connection ID. Alice then creates a connection request message for John containing this unique ID and encrypts this message with John's public key. Then she sends this message to John's profile server. And here the server does not know who has sent this package or what it contains. And then when John becomes online, he finds this package on his server, and now John is able to decrypt this message with his private key, which resides well protected on his mobile device. John can then decrypt this package, find Alice's profile reference there and this unique ID, and decide if he wants to accept or not. If he decides to accept, then he would create a new reader key for Alice, as well as package this reader key also into a connection package. Then John immediately activates this reader key on his profile server and sends this package over to Alice's profile server. And here again, Alice's profile server does not know who has sent this package or what it contains. But this profile server is now able to associate it with the package that Alice has prepared here based on this unique ID. And then the server performs a package exchange and returns the connection package for John, and also activates the reader key on the profile server. So from now on, this key can be used on the keys endpoint. Once Alice becomes active again, then she finds this connection package and the key exchange is complete. To protect against spam and unwanted connection requests, there's also some safeguards integrated in this protocol so that a profile server can walk you through a capture process, for example. Now, the last bit missing for a real social network are social interactions. When Alice posts an update, then I want to be able to react to this update, for example with a thumbs up or a like, or maybe I want to comment on this update. And Alice could even authorize me to post on her timeline directly. But to enable all of this, we first need to talk about these digital signatures. They authenticate the profile owner, and they prevent that any information not signed by the profile owner gets published on this profile. Now, if we want to allow other actors to contribute to a profile, for example with comments, then we need to introduce a mechanism to authorize other keys as well to contribute information. And this is done with signing certificates. We combine the public key we want to authorize with a set of permissions that we want to grant to this key. For example, the right to post or to comment. And then we sign this combination with our own profile key. This certificate can now be used in the signature instead of the profile key, as we can see here in this example. These contributions are then always done in the name of another profile, which is referenced here as the original author. But we can use these certificates also beyond social interactions. For example, it's possible to also grant impersonate permissions, which then authorizes this key to sign information really in the name of the profile owner. This mechanism is useful, for example, in scenarios where you have multiple devices or when you want to authorize a service to post in your name. If a profile accepts external contribution, then it needs to declare a publishing endpoint, like we can see here at the bottom. To prevent session replay attacks, or post-replay attacks in this case, publishing is always a two-stage process. You first contact this endpoint to get a publishing token, and this first request needs to be authenticated with your private profile key. This publishing token then gets embedded into the actual post as additionally authenticated data here as part of the signature. Then in a second request, you send this token back to the server together with the post you want to publish, and this is then authenticated with this token. Contributions can also be encrypted, which makes the whole process a lot more complicated. It requires us to use a separate publishing key on these requests to prevent that the server can associate our identity with this encrypted post. All of this is written down in detail together with a lot of examples in the Social Profile Exchange Protocol specification, which is developed and available here on GitHub completely in the open. This spec is intentionally limited to describing profiles, how information gets published in a secure manner, and how these profiles interact. But it does not describe how a profile owner can maintain and update the own profile server. Quite similar to HTTP, where the update of the web server is left to other protocols like FTP or WebDAV. This approach now enables many existing content management systems to immediately adopt the specification with minimal effort. There are two additional specifications, the Profile Management extension and the Service Provider extensions, which focus specifically on these aspects. This entire initiative is really aiming to foster an ecosystem where a multitude of organizations, individuals, and companies can step up, adopt this protocol suite, and all contribute to conjointly form a liberated social network which is actually owned by nobody. To help with this, we provide a Java reference implementation of the cryptographic operations, available under the permissive Apache license. This allows you now to use this library directly in your open source or even commercial projects. For example, you could throw this OpenAPI spec for the Profile Management extension in a code generator, combine it with this library, and then use it as starting point for your own Spring Boot-based service implementation. Or you can use this library directly in your Android applications. There are dozens of courses out there on Udemy teaching you how to build a photo sharing app. Just combine this with this protocol and you end up immediately with something useful. This reference implementation also comes with a command line tool, which can sign JSON objects, verify these signatures, encrypt and decrypt information, or create a new profile key pair. Since this tool is using only standard in and standard out, you can easily combine it with other tools like JQ or curl, and then probably even start talking this protocol directly from command line. To further support implementers of client applications, we provide a set of sample profiles here under testbed.spxp.org. On this page, you can find the profile links to the root document, as well as an extra JSON file which contains the private information which is typically stored on the devices, like the private signing key. These profiles have all been created randomly based on typical characteristics of real social networks, though they use the same average friends count or the same post rate which has been observed in popular social networks. And there's even a plugin for Wordpress to expose your site under this SPXP protocol. Here we can see a plain vanilla WordPress 5.9.2 installation, and you can find this plugin if you search for SPXP in the plugin directory. From here, as you can see, you can immediately install it into your instance if you click this Install Now button. After activating, you can then configure this plugin, how you want to expose your posts, and you can set a name, short info. You can even choose a photo from your media library. And then, as you can see here up and in the top, your profile is your site is then exposed under the SPXP profile, and if we open your profile URI, then you can find this JSON document which gets generated now by your WordPress installation. I just mentioned how you can combine this crypto tool with JQ and curl, and well, there's actually a bash script available providing exactly this. This script offers some high-level operations like profile setup or posting, and it uses these tools under the hood. And this is an impressive demonstration how simple it is to actually adopt this protocol suite. And it also provides some real value beyond just being a super cool tech showcase. For example, if you want your 3D printer to maintain a profile and post every finished object, then this script could help you. You can also find tools out there to back up your social media accounts, and by combining these tools with a script and then running them together in a cron job, you could maintain an SPXP profile which simply reflects your other social media channels. And there's even a Hubert script wrapped around all of this, so that you can maintain your profile directly from within Slack. To further seed this ecosystem, we started to auto-generate profiles and make more information accessible through SPXP. Here on commons.spxp.org, we provide a set of static profiles, for example, representing cities. We took information from geonames.org and combined it with data we scrapped from Wikipedia to generate these profiles. So they all come with a profile picture, geodetic coordinates, description, and so forth. And we are planning to extend this to more countries and also to cover other common entities as well. And then here on start.spxp.org, we have an initiative to kickstart this ecosystem. Currently, we only have a list of a couple of profiles which post web links to local news, which we are crawling periodically, but we are planning to really extend this and make it a real starting point, for example, by providing a list of famous profiles or a directory of social media accounts, which now started to publish under SPXP as well. And there's a first commercial mobile app out there as well, the Hey Folks app. And now I'd like to use this app to give you an impression how all of this can look like from the point of view of the average social network user.